Alright, lesson 6.4 is all about doing what we've done in this entire unit but with less numerical values. So some of you will have noticed while we've been doing this unit that essentially we are doing exactly the same equations and the same things all of the time. So what we can do is we can generalise that, can't we? We can come out with general formulas of what's going on. So firstly, we're looking for the time of flight t. So we've got a setup here where it tells you that u is going off at this angle of alpha. I don't know if you can see the alpha, but I'm sure you've got it in front of you. That's an alpha here. Not the best printout in the world that I've ever seen. But basically, the time of flight is how long it's going to take to be. So in order to do that, we'll resolve vertically. And when we resolve vertically, what we're looking for is we're looking for a value of s that's equal to 0. And what we're going to do is we're going to have the initial velocity is u and it's sine alpha because we've gone away from the alpha to get to the vertical, so it's u sine alpha. We've also got that we need to find t and we know a. Now if we notice in this question it says that acceleration due to gravity is g, so it's not telling us it's telling us not to use minus 9.8 now, it's telling us to use g. So if the acceleration is g, it's still going down, then the acceleration is going to be minus g. So we can find an expression using this for the time of flight t. And the way we do that is just like we do normally, we use s equals ut plus 1/2 at squared, is 0 equals u sine alpha times t minus 1/2 g t squared. So what does that give us? Well, if we rearrange it, well actually no, we won't rearrange it. What we'll do is we'll take out a factor of t. So it's t u sine alpha minus 1/2 gt. So this one gives us that t is 0, right? And then we solve this equation. So this equation will be that u sine alpha must be equal to 1/2 gt. So I times by 2 divided by g, and I get 2u sine alpha divided by g is equal to the time. Right? And that is the generalized equation for how long a particle in this situation would stay in the air. So all we need to do is find out u, alpha and g, and we'll be able to put it straight in and find out the time. We've done that process lots of times in this unit, right, to find that, including the factorising of t out, but we've just done it with numbers rather than these algebraic terms. But other than that, it's exactly the same. The second part is to find the range r on the horizontal plane. So r, the range, is how far it's gone when it does land. So that one is going to be all about resolving horizontally. We're looking for s equals r, the range. And what do we know? Well, we know the time. We know the time is 2u sine alpha over g. We know that the acceleration is 0. And we know that the initial velocity is u cos alpha. So if we pop that into our equation, so we've got s equals ut plus 1/2 at squared again. And we'll see that r is equal to ut, but then we've got a equals 0, so that's going to kill just like it has the whole time, that 1/2 at squared, and we're just left with 2u sine alpha over g times u cos alpha, right, which is equal to 2u squared sine alpha cos alpha over g. And the question's a little bit cheeky because the next step is not what they ask you to do, but they would generally give you the answer they want you to get to, because there's something that I've noticed here. And what I've noticed is, look, if we write the u squared over g out over here, right, then that's that multiplied by 2 sine alpha cos alpha. And if we remember from our pure work on trig, 2 sine alpha cos alpha can be written in a different way. So this is u squared over g times by sine of 2 alpha using the double angle formula. And that's more commonly what you'll see for the range. I know the question didn't ask me to get this far. I think if the question had asked it like it did, leaving it in this format would have absolutely been fine, but you're more likely to get them to say, show that the range is u squared over g times sine 2 alpha. And that's as simple as we can get it. Okay, so that's an algebraic expression for the time of flight and an algebraic expression for the range as well.